Hi, so for today we'll be talking about the power outage prediction tool for electric utilities. Now we will use the CRISP-DM process. Now on the business understanding phase, so we should define the problem. So on the target user, so the target user would be the electric utility director of operations. Now for the problem is they need to decide 2 to 3 days in advance how many crews to call to repair the expected storm damage. Now, why does it matter? So, it matters because if they call too many, what do you call this, crews, so they waste significant money because they would pay them for their wage. And if they call in to few customer, if what do you call this, if they call in to few crew, so the customers would be upset because the time that will be repairing would be very it would take time. So the current state, so what would be the current state? So they use weather forecast and their own intuitions to make an educated guess. Now next would be define the success. So the expected impact on this would be improve restoration times and minimize wasted cost. So let's talk about the metrics. So the outcome would be reduction of average restoration time, and the output and the target would be the outcome would be reduction of average restoration time. Now on the constraints, so the prediction must be delivered 48 hours in advance of the storm would start. Now, next would be the identify factors. So we have three here. So the weather, the density, and the trees. So what should we consider on this weather? So for example, the wind, gust, precipitation, the strength of the what do you call this? The wind. So on the density, we have the location or concentration of assets. Meanwhile, on the trees, you have the proximity to power lines and the seasonality. Now, the phase two would be I yeah, data understanding. So I should edit this. So this would be the source data. So sources is on the weather, we have the weather providers. On the trees, you have satellite imagery vendors. And on the density, we have utility customers. Now, on the historical outages, target would be the utility customer. Now, for the consideration, how much data do we need? So, for example, we need data for the past 2 years, 3 years, uh, what do you call, up to 5 years now. On the sensitivity, we would be talking about for example, the strength of the wind, the rain, the etc. Now for the cost, we have this talked in also in the problem itself. Now on the data understanding, we still have the validate data, so we have the missing data. For so this would be a significant change to the data that would need. So next would be the map disparate source to common geospatial resolution. Next would be the outlier storm. So this would be major outages. Now in the data preparation, we have defined features. So we should consider many possible features. For example, the weather parameters, the time scales, the interaction between features, possible missing features. Next would be the modeling. So we have two choices here. So first would be balance of performance and interpretability. Uh, Next would be the single model or tailored models. Now for the evaluation. We have the evaluation results, so performance on test sets. So next will be the customer testing or live data. Next will be debugging or data issue. And that would be all. Thank you.